Welcome to the training on the basics of working in virtual space. To control your actions, you'll need the controllers you're holding in your hands. Take a look at them. Under your index finger, there is a button, the trigger. Use it to select and activate objects. Try it out. Point the beam from your controller at the Add Microscope button on the screen in front of you and pull the trigger. Great! You've activated your first object. To interact with objects, move the controller closer. When a blue highlight appears, press the trigger to turn on the microscope. Excellent! The microscope is on. To move objects, use the button under your middle finger, the Grab button. Take the microscope and move it to the marked spot on the table. If you don't remember the current task, press A to get a hint. Press A to get a hint. Excellent! Task repetition works. In our laboratories, you have access to a tablet with hints and tasks. To open it, bring your right controller close to the brace. You can move the tablet by holding the Grab button. Try moving it slightly. The first tab contains hints for the current step. The second shows the list of all tasks in the level. Open the second tab. To close the tablet, bring the controller back to the bracelet and press the trigger again. Great! Now, let's learn how to move around the space. Use the joystick under your thumb on the left controller to walk to the second table. Go to the area marked with... Go to the table and pick up the sample. To lift it, press and hold the Grab button. Then move the sample to the microscope and place it to the right of it, in the marked area. Excellent! All steps are completed. The virtual workspace training is complete. Welcome to the laboratory for studying thermodynamic processes. Isoprocesses are thermodynamic processes during which the amount of substance and one state parameter, pressure, volume, or temperature remain constant. Changes in thermodynamic process parameters are displayed on the diagrams shown on the board. Select the graph showing the dependency of gas volume on temperature. Select the graph showing the dependency of gas pressure on temperature. Select the graph showing the dependency of gas pressure on volume. Excellent! Let's proceed to study isoprocesses. An isobaric process occurs at constant pressure and mass of gas. To monitor parameter changes, we use sensors on the cylinder. Pump gas into the cylinder using the pump. Insert the controller into the pump handle and press the trigger to pump gas in. The pressure in the cylinder remains constant and is determined by the gravitational force acting on the movable piston. Turn on the heater and observe how the system parameters change. Insert the controller into the valve and press the trigger to... We observe isobaric expansion. When the gas is heated, the volume increases and the pressure remains constant. The pressure stopped increasing when the system reached equilibrium and the heating and cooling energies of the cylinder equalized. Now, turn off the heater to let the gas return to room temperature. Insert the controller into the valve and press the trigger to turn off the gas heating. Select on the board the correct description of what changed when the heating was turned off. We have implemented isobaric compression. As the gas cooled, the gas volume decreased while the pressure remained constant. Excellent! We have studied the isobaric process. Open the exhaust valve. Insert the controller into the pump valve and press the trigger to release gas. An isochoric process occurs at constant volume and mass of gas. Now we are using a closed cylinder inside which gas has already been injected. Turn on the heater and observe how the system parameters change. Insert the controller into the valve and press the trigger to turn on the gas heating. We observe isochoric heating. The gas pressure increases while the volume remains constant. The pressure stopped increasing when the system reached equilibrium and the heating and cooling energies of the cylinder equalized. Insert the controller into the valve and press the trigger to turn off the gas heating. We observe isochoric cooling. The gas pressure decreases while the volume remains constant. Excellent! You have implemented an isochoric process. An isothermal process occurs at constant temperature and mass of gas. We are underwater. This allows maintaining a constant temperature of the gas in the vessel by rapidly compensating heat release or absorption. The gas is already injected into the flask. Our task is to track how parameters change with changes in the gas volume. Slide the piston to the right to increase the gas volume. Select on the board the correct description of what changed when the volume increased. We observe isothermal expansion. When the gas volume increases, the pressure decreases while the temperature remains constant. Slide the piston to the left to decrease the gas volume. We observe isothermal compression. When the volume decreases, the pressure increases while the temperature remains constant. Excellent! We have implemented an isothermal process. Open the exhaust valve. Congratulations! The isothermal process has been studied in practice. It was demonstrated how volume and pressure change at constant temperature. Excellent work. Check your acquired knowledge. Note that during the process, the temperature remains constant and gas volume decreases.